That's for you.
Thank you. Oh, all right. I think we're live.
You'll have to share one. I'm sorry.
Can you ad lib for just a second? Like just say funny things. I'll be back.
Hi. Okay.
Eat
Should I
some
do
ice
it
cream.
in Statquest mode? Bam. Oh, we were gonna start that. Okay. So hello everybody. We're live in YouTube and LinkedIn, and hi everybody here. You're the MC, so I'll let you begin.
I'll wait for
Okay.
Josh to return with
So
his
we have to
special.
change the mic to.
Yes, or you can have
You know,
mine afterwards after my
In my
moderation.
family, we're so loud that we have to have like a salt shaker or something when people talk, and we pass the salt shaker. Whoever has it is the only one allowed to talk, but then we just start grabbing it from each other. So, but this is like the salt shaker in my family, basically. Sorry.
Hello, me and Lewis gonna answer your questions, moderated by Philippe. Hooray! Uphill Conference 2025. Bam!
All right.
You already heard it. Welcome to the Q&A session with Luis Serrano and Josh Starmer. Josh Starmer from the popular YouTube channel StatQuest with Josh Starmer, and Luis Serrano from his popular YouTube channel Serrano Academy. And you already know who these people are, but we are in the first ever live Fireside chat. You heard it. We stream out live to all the communities, so maybe I will repeat one or two of your questions. That's why we wear mics. And for all the people that aren't here at the moment, I need just a short second to introduce where we are. We are in Switzerland, in the capital, on top of a mountain called Gurten. And normally we have huge musical festivals, and we put it all aside for you two guys. So welcome to the Q&A session.
Who needs rock and roll?
Who needs rock and roll? For the people online, you can put in your questions on LinkedIn. I'll look at my tablet and we'll ask them here. So for the questions, I know nobody wants to go with the first question, so I thought about one. And I looked online, like, what can I ask these two guys? These superheroes of AI that hasn't been asked before. And I came up with the perfect question. You can go first, Luis. If you were a furniture, which furniture would you be and why?
Wow, that's a very good question. I feel like if it's gonna really tell about my personality or something, like it's a psychologist. I would say I would probably a beanbag in front of a TV.
A beanbag
Like one
in
of these
front of
really
a TV.
nice
Okay, why?
beanbag.
I have to know why.
Well, first of all, it's very comfy. First of all, it's in front of a TV, so I would have fun. It would be comfy, and it's one of those things that it's flexible, but every way you put it is comfy, right? Like you can put it in different ways, but you can't go wrong with a beanbag, right? Or at least I haven't gone wrong with a beanbag. So, beanbag in front of a TV.
Josh, you had enough time to think about it.
I know. Yeah, exactly. I cheated. I would like to be the dinner table.
Interesting.
Because I like cooking for people. I like feeding people, and I figure if I was the dinner table, then that's what I would do every day. People would just come and sit around me and eat. It'd be great, fun.
French fries, like in your
French fries,
presentation?
yeah. People would come for French fries, whatever you want to eat. They could put it on me, and I would just hold it up while they ate it. That'd be fun.
Thank you very much.
I love that your solution was helping others, and mine was like, I just want to hang down.
That says a lot. So the round is open for questions to our two YouTube channel superheroes. What questions do you have?
Best gelato I've had. We had some great gelato in the conference.
Yeah.
I've been wondering about something. Like nowadays, AI is based on large language models, like human languages. And do you think this is really the optimal way to speak with artificially intelligent machines compared to more formal languages like mathematics, code, structured things? Because I tell you one thing. I work with code. I'm a developer. And if I want artificial intelligence to produce some code, first I have to say it in English. It may be ambiguous. I have to know, no, that's not what I meant. Not this variable, the other one with the same name that was there. If I want a structured response, I have to write in English. Please reply in JSON. Please, no, not XML. Really a JSON.
Yeah.
Is English really human language really the best way, or do you think we could improve on that with more formality?
Great question. Right. You got it.
We have two of them.
Oh,
So the question was: is human language the best way to train a large language model, as opposed to formal mathematics or some other thing? And this is not going to answer your question at all. So just prepared to be disappointed. Wholly ready. Here comes my answer. Personally, I would like to not redesign the model to begin with, but my background is in biology. I was a geneticist for a long time. 13 years, I was a professor in genetics. And it is my dream that they start creating models that are maybe a little bit more biologically based, or like modeled on actual biology. The history of neural networks goes back all the way to the 1950s, so 70 years ago. And back then they were trying really hard to model how actual neurons worked. And that's where it got its name of a neural network. But as things have progressed, some of the biggest innovations came from people going, well, I know we're trying to like model how a brain works, but this isn't working, folks. And so then they throw away some key aspect of like, maybe like a standard dose response curve on how a neurotransmitter would work, and in favor of the ReLU function, which is pretty arbitrary but easily computed and works really well. And all of a sudden, like, neural networks could do interesting things. And then when ChatGPT came out, it was cool and everybody liked it. But in contrast to a lot of the publications that had come earlier, there was absolutely no effort to show how any of it related to sort of human neural anatomy, or any neural anatomy for that matter. And I wonder, what I wonder is, because we're a language-oriented people, that's how we learn, right? We learn a lot. I mean, we learn visually, but when you go to school, your teachers talk to you. When your parents try to teach you what an apple is, they hold an apple up in front of your face and they go, "This is an apple," and they keep saying it to you. And eventually, the concept of apple takes root in your head. I feel like we are prone to teach anything the way we teach ourselves. And if we're going to take that approach, so this is sort of like a backwards way to answer your question. We're going to take that approach. I feel like we need a model that maybe is a little more representative of ourselves. So like I said, yeah, disappointing deluxe, but that's my 2 bits. Here's Lewis.
Yeah, great answer. Yeah, I think I'll add in the same direction. Actually, first of all, your question kind of has like maybe a 2-parter, because one thing is about if language models talk, if this is it for how language models can talk, and I think we're not even close, because the way ChatGPT works is one word at a time, and I think that's crazy. I'm surprised it works so well that it just talking one word at a time. I hope that's not how humans talk. I hope we plan what we say. Maybe not all of it, but like, I would say that a good model that talks would plan what it's gonna say, more like an image model, right? Like in an image, you don't do pixel by pixel. You actually have a rough image and then clean it up and then clean it up. I think a good learning language model, and hopefully the next stage of maybe diffusion models for LLMs, will say something, think something rough, and then clean it up and then clean it up, and sort of think what it's going to say, so it's be able to say things ahead. So that's for that. And as for the human language, I think I agree with Josh. I think it's a huge bottleneck. There's actually, I think of in mathematics, for example, you have a huge bottleneck, which is proofs. Right? There's not that many proofs, and there's more true statements. So there's a bunch of things you can't prove. You go through a bottleneck. I feel like we have language is a huge bottleneck because there's a lot more things that exist than the things you can say with with language, right? And so I think, unfortunately, humans go through the same bottleneck, right? There's many concepts we can't comprehend because the language can't put it together. So I do hope that some language models may be able, or future models will be able to discern things that are beyond a language understanding.
One of the things that I think Lewis has a fantastic example. You're talking about how it's annoying that language models just think one word at a time. And at the time, I was like, well, Lewis, you're clearly talking one word at a time, right? so I was like, I don't really get what he's getting all bent out of shape about. But actually, Lewis has a fantastic example of how even though we speak one word at a time, just like the large language model, we're clearly thinking ahead. And your example is the fact that large language models can't make good jokes, right?
Yeah.
And I think that's like, what we can make a good joke because we can think ahead and plan out a punchline that's novel. That's like I'm going to steal your thing.
Please,
is
yeah.
like, and maybe you can correct me if I get it wrong, but the idea being, like, what makes something funny is often there's an unexpected aspect of it, right? And it surprises us. And part of the what makes it so is that surprise. But the thing is these large language models basically just give us the average of stuff. So they can make bad puns because there's lots of bad puns out there, but they can't really generate this novel thing that you need to lead up to with a huge build up to then all of a sudden surprise the person and make them laugh at the very end. It doesn't, that's just not fundamentally, that's not how it operates, but we can do that. At least people that are funny can do that.
I think you're right.
Anyways, so some people can do that.
I have a question from the online community, which I think adds to this one. How you both balance between width and depth of learning, given the speed which the AI space is changing? How do you balance width and depth of learning in such a rapid environment?
The first thing I do is get overwhelmed. It's so fast. I have a secret weapon though. I have a YouTube channel, and people will post comments about what they want me to talk about, and I can kind of keep a finger on what's the big trend or what's the biggest trend by doing like a mental histogram of what people are asking me to try to explain. And so that's my secret weapon. I'm going to be honest, I'm going to do a shout out to my buddy, Sebastian Roschka. He has a fantastic newsletter. That guy reads like 50 papers a day. And he's got this newsletter where he summarizes the essence of them. In some ways, I'm a little nervous that he's going to get replaced by a chat GPT or something to like, you just give it a pile of articles and just say, summarize it. And to be honest, that's not a bad approach these days. But Sebastian he takes it one step further and offers some of his own insights to highlight things that he, as a practitioner, someone who's been involved in neural networks and large language models for a long time, he brings that expertise to it. I don't actually know the name of his newsletter, but I just get it in my inbox. But just look him up. He's a fantastic educator, and he's a great sort of resource to have if you want to keep track of what's going on in the field, but you don't want to be completely overwhelmed. Even though I am overwhelmed by his emails, because he'd be like, I just summarized 200 manuscripts or something like that. And I'm like, can you just summarize 2 of them, like the most important? I don't know. But it's better than nothing.
Yeah, that's definitely a good newsletter. I want to throw in Jay Alamar's newsletter as well. He has a good one that's very keeps you up to date. Yeah, I think to me, my life got better the day, and my mental health the day I stopped feeling guilty for not knowing a lot of AI stuff. Because if you ask anyone, they'll be like, "Oh my God, so much stuff!" And I'm just at some point I was like too much, and it just exploded or something. And I'm just like, it doesn't matter if I don't know a bunch of stuff. And I just try, the YouTube channel helps me because people start asking for a particular topic, and I realize that that's probably important. Or if you hear a buzzword or something, I try to learn the stuff that I find fun for me. And I'm slow, so sometimes technologies completely skip me over. Like it takes me longer to understand it than the technology to actually rise and go back down. So sometimes I'm like, okay, good. I didn't have to learn that stuff. So sometimes that technology completely skips you over. That's fine. I think as long as you're always, I don't know, learning something, enjoying something, there should be no guilt, because there's way more stuff going on in AI that we can fit in our time, in our day. So yeah, just know a few things, and if there's something else, somebody else will know it, and then as long as we all kind of figure it out together, we're good.
Yeah. And I'd like to add to that, and that, yeah, there's a lot. I mean, like I said, there's like every day, there's so many manuscripts that come out, so many papers, so many new technologies. But what I look for are big changes, not small incremental changes. I mean, small incremental changes are helpful and useful and give us models that are better and a little more interesting. But to be honest, I don't find that kind of stuff interesting. So when like a new model gets updated and it's been, what did they do? They added more parameters. Okay, fundamentally, nothing has changed, right? They just made a bigger model. That to me it doesn't register as like something really worth worrying about. That's something that, when the time comes and I need to use a model, sure, I'll look into it, but I don't need to know it, because that kind of stuff is going to change. Like 2 months from now, someone else is going to release a bigger model or a better model or something like that. So I try to look out for big changes rather than incremental changes. And I just let all the incremental changes, they can just blow past me, and I'll just look into them when I need them, rather than try to proactively learn all the stuff so I can spout off the numbers and say, oh, this model is, blah, 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 blah. That's not my personality, but it's also, I don't think, really worth a lot of time unless your job is to be like a sports commentator for large language models.
That'd be a good job.
Yeah, it would be a good job. Yeah. Yeah.
I have, like, just hearing you talk, there's a certain like calmness about how you approach LLMs and this rapid change of like development. And I'm just wondering, for people who are sort of just seeing the surface level changes, it might look like every week there's like a reinvention of the new world. So what are sort of the core principles, or maybe core fundamental things that we should learn, so that we can actually decide and gauge whether this thing is an incremental piece of news, or it's actually a big thing that I need to like drop everything and get started right away? So are there any 1, 2, 3, like 3 things that we could go out here and maybe start looking into?
Yeah, the good news, I would say, is that even the big changes, or maybe there'll be one that's completely fundamental, but even the big changes are built with the same blocks as the previous stuff. For example, when ChatGPT came, I had no clue what it was. But when you look, it's like, it's a big neural network with a bunch of rocket boosters attached to it that make it go faster, right? So if you know neural networks, so definitely neural networks is something to know well. I would say, yeah, like if you know the fundamentals, and a lot of like how to evaluate models, like if you know the basics really well, you can build anything on top, because a lot of the things coming out now is just a neural network used in a different way. Like you look at diffusion, it's a neural network that's used to clean up an image, and then normally, yeah, like if you know the basics well, then you can build on top of that. So yeah.
So I just did a podcast interview with a bunch of hiring managers from a handful of companies in Silicon Valley, and this was interesting, because they said that one of the biggest misconceptions that people trying to get jobs in tech have is that that companies that are hiring want them to know the latest, greatest tools. And you think, well, yeah, obviously, but they're like, no. What they really want are people that know the fundamentals. And what it boils down to is, even though we use these great tools and they can make our lives faster, and we can use ChatGPT to write a great cover letter for some job or whatever. According to these hiring managers, linear regression is still just as sexy as it was 100 years ago. And they're like, that's the problem, is we can't hire people with solid fundamentals. because everyone is trying so hard to chase the latest technology. And they said most businesses need a little bit of that, but they need a lot of the fundamentals. And so they're looking to hire more people that just have basic fundamental machine learning and data science skill sets and aren't necessarily always on the cutting edge of stuff. And so that's another thing that makes me sleep at night, because that means my video on linear regression will still get views.
That doesn't go away.
And that's nice to know. But how do you look out for a big change? I will say one thing. That's a good question. I'll admit, how do you find a change? But I will say when ChatGPT first came out, I was actually at NeurIPS, which is this big AI conference in the US, and I was in that, there's this floor, the vendor floor. It's this huge conference. So we're in this big convention center, and all the vendors are there, and everyone's talking, and you go up to the Meta thing, and they've got Jan LeCun, and you can get his autograph. I'm like, yeah, cool, blah blah blah. And then ChatGPT came out, and the whole room got silent because everyone was just going, "Can you explain how Transformers work with a pirate voice?" And it would respond like, "Arr, mateys," and everyone was like, "No way!" Everybody's mind was completely blown. And I think that doesn't happen all the time. And I'm trying to think of in my lifetime, it's happened probably maybe 3 times in the past 25 years. The first thing was ImageNet, I think, was the big breakthrough when they finally figured out how to make neural networks do image classification. Because ImageNet all of a sudden meant we can start making self-driving cars, right? Because now we can identify stop signs, people, pedestrians, bicycles. That's a game changer. That changed the whole industry. I think the next one might have been ChatGPT. Maybe there's only been 2 in my lifetime. So the good news is they're big when they happen. They're game changers, and we're in the middle of one, but I don't think anything that's come out since 2017, which is when the original ChatGPT came out, or the original Transformer came out. ChatGPT was 2022.
Yeah.
Transformer came out in 2017. We haven't had a new architecture that's really taken root since then. So 8 years. So I don't know, maybe we're due for one.
Maybe
keep your eyes
maybe
peeled.
quantum or something.
Yeah, quantum.
But
yeah.
That's great. I'd like to also add that there's 2 ways you can understand something, right? You can know how to use it, and you can know how it works really well. So if you know how the basics work well, linear regression, neural networks, Bayesian stuff, and then the latest stuff, you know how to use it, and you slowly move towards, like, maybe to the center, learn more of the fundamentals to get to a sweet spot. You don't need to know how, like it can be a while between the moment you know how to use something to how you understand it. And if it's for like interviews or something, you can always, they always ask for a lot of stuff. You can just learn the stuff before,
Sure. So it's related to what you said with the newest stuff, but more in the field of, let's say, AI research at large. I feel like the last couple of years, the trend was kind of go bigger, get bigger models, evaluate on bigger benchmarks, and then even bigger, and then also multi-model and bigger. And now I think we are starting to shift in a trend. I think you talked about NeurIPS before, who for this year posted in their submissions that they encourage more in-depth evaluation of like the mathematics and fundamentals of the models that work. Like, I would be really curious how you feel about like how we research AI right now, if we are researching it in a way that makes sense to advance, or if we are maybe trying too much to just have bigger parameter scopes and whatever, and therefore are going to get stuck at some point.
Yeah, so the question was, to paraphrase, is the current research in AI, is that heading in a direction that will create the next revolution? Is that essentially, or is it going to lead to a dead end?
Or are we going to run out of training space at some point?
Yeah.
It's just going to get stuck.
Yeah, are we just going to get stuck? Yeah. And I think that's a great question. I'll just tell you my personal opinion. I think we're going to get stuck. I feel like we've been here before. I mean, it's cool. We've got a great toy. I think with the current architecture, like what we're saying in terms of trying to get a transformer to tell a good joke. The current architecture, we haven't had any significant changes to. All they've done is make it bigger and spend more money on it. That's not really innovative. I mean, in a way, it is. To roll back a little bit, there was initial innovation in that when in 2017, not the sole purpose, but the driving factor of the transformer design was, how do we remove the training bottleneck that we had before? And once we remove that bottleneck, the amount of data we can use for training becomes limitless, relatively speaking. Before, we had a specific bottleneck in how to train these models, which is you had to do it one token at a time. Now, that's the way it generates output, but when you're training it, and we're not interacting with it and asking it funny questions like write a poem about stat, squatch, and norm. When we're training can actually all be done in parallel. And that was the big innovation. It's not necessarily any particular part of the thing, but they figured out how, instead of going one token at a time during training, they just said we can do it all at once. And as a result, the throughput, is orders of magnitude faster in terms of training. And that was the single biggest. So in a way, and all of a sudden then they could go from having a small data set, relatively speaking, to one 10 times, 100 times, 1,000 times larger. So that was the innovation. But since then, we've just been using more and more larger data sets and longer training. And that's really, I mean, then they've come up with cleverer ways of prompting. We're learning it. I feel like that's maybe an evolutionary thing where we're learning how to prompt, but I still feel like that's not a fundamental change. Like, we're still just saying, we're still using the same technique we used in 2017 to build models in terms of just throwing data at it.
Mm-hmm. Yeah, I'd like to add that I also think we're gonna get stuck maybe in the way that most technologies are, like smartphones, for example. The difference between one and the next one is so much smaller because it's almost invisible than between the first one and the second one, right? So that may happen, but every now and then you get a bigger jump, right? Like, we were getting better in neural networks to talk, and then they had RNNs that can talk a little better. And it was pretty clear, I think, that it was not a huge RNN that was going to be ChatGPT. You needed something different. So they came up with attention, which looks way far behind in a smart way. So every now and then you do have this big conceptual leaps, but a lot of the small steps are just either better hardware or better, like, fast algorithms to train the exact same model or something like that. But I think for the beginning of your question, it's like sort of like how AI research is done. I feel like we've done that before. I feel like it's like with fire, when we discovered fire, then we started knowing how to use it and how not to use it, and how to not use it to get burned, but use it to cook. And it was a while before somebody found out, like the scientists found out what exactly is fire, right? And I think we do that in AI. Like, we just somebody comes up with a model, has no idea how it works, but like starts using it and works really well. I don't think we fully understand neural networks. Like, we know there's mathematical reasons why they can approximate anything. And we have a good mechanism to get it close to an answer, but nobody can tell you what happens in the second layer of a simple MNIST neural network, So that's definitely, we're in the fire part, like, we know how to use it. So I think that the understanding goes a little behind. So it's, yeah, I hope that we get to understand all the things that are working now, and other people work to make some better ones. So I don't know. I think I had a professor who used to say, if I knew what I was doing, I wouldn't be calling it research. And I think that's where we are. There's not an exception.
That's awesome. Yeah. I love that fire analogy too, right? I mean, we went thousands of years, like, just saying, hey, this is a very useful thing. We don't really understand it. In fact, it's
Magic, it's a demon.
yeah, exactly. People thought all kinds of things, and there's a long-standing theory called phlogiston theory, where they thought there was some essence within the wood called phlogiston that and so it's actually, I mean, in the history of science, it's a great sort of case study of how there was a dominant theory out there that worked pretty well up until we got better at chemistry, and then all of a sudden it fell apart. But we had to develop all these other things to realize that this dominant theory wasn't awesome. And that's just how science works. And neural networks are no different from that. They're a useful tool. I'm a rambler, so I'm going to ramble a little bit. I know that the statistics department at Stanford University, they're the legendary, some of my heroes, statistics. I do love statistics. Some of my statistics heroes work there. And they've talked about this too, how they feel like they're doing everything they can to catch up with neural networks. It's moving too fast, but they're doing everything they can, and sooner or later they're hoping that they'll be able to catch up, and they'll be able to formalize why certain things work, like word embedding, right? Word embedding is one of these things that has no mathematical proof that it will actually work. We observe that it works, and we go, oh, cherry ends up with the other fruit. But we don't actually have a mathematical proof that should happen every time, which I think is interesting, right? It's something as basic as that. Because if you ever looked at a basic word embedding network, they're as simple as they get. They've got one hidden layer. They don't even have bias terms. They just have a bunch of weights going into the hidden layer and a bunch of weights coming out, and that's it. And people are like, it works.
What was that word? Phlogistics?
Yeah, phlogiston theory.
Phlogiston theory. Okay.
Yeah.
I wonder some in the future will talk about us like that.
Yeah,
Oh, they used to think regularization worked.
Of course they will. Of course.
You guys both think we're going to get stuck in this current paradigm. Why don't we go back and study the brain? Because we have prior art, like the brain works.
Yeah.
Why don't we study like that?
I think.
Repeat the question.
Oh yeah, thank you. Good question. A good. The question is, if we're gonna get stuck, why don't we go back and look at how the brain works and emulate that? So I think, correct me, but I think that originally neural networks are made to emulate the brain, right? Hopfield networks was sort of the precursor, and it was basically made not exactly, but grabbing the right analogy of saying, okay, if two neurons have always fire together, then they get closer, wire together, so you make this edge have more weight, and then neural networks became more and more. So I think they're already looking at the brain, but I think the key is to look at what's needed and what's not. So I asked a friend of mine who's expert in neural networks. I said, how much more do we need to get closer to the brain? And he said, well, sometimes you need to really emulate, and sometimes you need to know when not to emulate. And the example he gave me was with airplanes, right? When humans started making airplanes, the first thing we did is let's emulate a bird, right? So the first airplanes all flap the wings, right? Like they just have a bike that flaps wings, because we thought if they flap the wings, we need to flap the wings. And then they later realized that it's not the flap the wings that you need. What you need is the drag that comes from. So keeping it straight, like still, actually did the job, because they didn't need to flap the wing, they need to emulate the drag. And so I think the brain is going to be like that. We may not need to emulate the whole thing, but a few things need to be mimicked, and others not. So yeah, it's a great question.
I think that's a great Louis has a fantastic answer to that. I think it's great, and that some parts are more important than the others, and we don't yet have a great way of discerning what those are. That being said, another factor is possibly we need innovations in computer hardware. It could be the the computer architecture, other than these what do we call them? What's that thing?
GPUs?
No, not GPUs. The kind of computer you used to work on. The with the subatomic particle thing.
Oh, quantum
okay. Stuff, right? Okay. Other than quantum architectures, the fundamental architecture in computing hasn't changed since it was mathematically formulated by John von Neumann, way back in like the 20s or the 30s or something, like before they even had computers, right? They were like, we've done the math. This is what a computer will be. And we've been doing that ever since.
Sound like a caveman,
Yeah,
really.
right. And we're like, well, it works. We've made it faster, and but fundamentally the architecture's never changed. And that could be is that how a brain works? I don't know. I mean, so there could be a lot of innovations that need to happen before our models get more sophisticated enough to actually model sort of the neuronal interactions. One thing I think is interesting about how we learn, right? When we learn in our brain, and I'm no neuroscientist, so I could be totally wrong and making this up, but my understanding from what I gathered from watching TV is that when we learn, our brain physically changes. Neurons grow and start poking at other neurons that they weren't poking at before. We've actually, like, the learning actually changes the physical structure of our brain. And I think that's something maybe we should look into. Can we have a model that changes physically, not in software, but the equivalent of a physical interaction that didn't exist before, a connection that didn't exist before? Can we model that kind of thing? I don't know. I'm curious. As one of those people that's like a couch potato neuroscientist, I'm fascinated by this. And I would love for them to figure it out. So those are my thoughts.
Yeah, I'd like to add quickly. I think even looking ahead, maybe the brain is also a bottleneck. Like, I think there's a lot of stuff, like maybe AI will be able to be better at brain stuff than us, just like cars are faster than the way we walk, no matter how fast we run, right? And I feel like we should start looking for things that are not the brain, and that's how we're not gonna get replaced, right? Like things like emotions, things like empathy, things like intuition, and you just have this spark. Like those things may be what tells us apart from these models when they finally become, like, I don't know, they're already smarter than us, but they're getting there. So even emulating other things that are not the brain may be the way to go.
Just want to comment that yes, I don't think the brain is perfect. Like, I wouldn't want my computer to be bored, distracted, angry, jealous, and all those emotions. Like, we have the intelligence and we have emotions that are not always good. So I don't know if we can somehow have intelligent computers that do the things we want it to do, but not so much those emotions.
The question was a good question. That would be scary if the computers had emotions and then they would start taking decisions out of there, right? I think we're pretty safe there. I don't see computers making decisions based on emotions, because they make decisions based on numbers. And so when as humans, like, we can make a decision purely based on numbers and facts, or we can make it based on something we think or something we feel. And I think that's what computers cannot do. Computers always, every AI algorithm, no matter how advanced, if you look at an AI paper, it's always like, you look and then there's the loss function. It's a big formula, and that's what you have to minimize. So they always take decisions based on one variable. When I don't even know how we can not do that.
Yeah.
Like maybe a quantum computer. There's a quantum computer part that is completely random, and that may well entangle with a higher conscience or something. We don't know, because it's fully random. But as far as a classical computer, I don't see how it can get out of making decisions based on numbers. And when we make those decisions based on it, is when we're the least human. We just do an Excel spreadsheet, and if it said yes, then we take the decision or something. So I think that's at the level that they are.
Yeah.
We got philosophical really quickly. Yeah? Normally this happens after it's the gelato.
It's the ice cream.
It's the
Yeah.
ice cream, yeah. All right. Yes.
Since you're both running like huge YouTube channels, I'm sure you get a lot of questions, and I'm just curious to to understand, like, what are some of the misconceptions that people still have in 2025 where you think, like, why? You know, are there any things that just surprise you that they come up again and again?
With respect to what? So the question is there something that like still confuses me now that it's 2025? Why do people still do something or
Why do people still ask the same thing?
Oh, yeah.
That should have been resolved, you know, from your perspective. Just like common misconceptions.
Yeah.
Common,
That's a good question.
like, wrong beliefs or anything like that.
I mean, it is 2025, and I do have a bunch of videos on how neural networks work, and they're not brand new. They've been around. People should know. No, that's kind of funny. That is kind of funny. But I mean, I think it is interesting that people think a lot of technology still is pretty magical.
Yeah.
You know, they ascribe sort of like, oh, I can't understand this. Because it's technology and therefore it's not, you know, I don't think that way. I think that always kind of surprises me that it's 2025 and there's still people that sort of reject the very concept that they could comprehend the sort of man-made world around them, the artificial world that we've created. I mean, I feel like it's understandable to not understand all of nature, right? Because it's so complicated or things, but the things that we've engineered are based on fundamentally pretty simple things because especially compared to nature. And so I think it's interesting that there's a lot of people out there that just automatically shut down and just assume that it's impossible to understand. And
yeah,
that's for me. Yeah,
that makes sense. Yeah, I have that from like questions in YouTube, not so much, but I tend to, my talks, I tend to ask a lot of questions, and many times I notice that there's still a common misconception that maybe for less technical people like that the computer is kind of a human. You know, it's because when I try to think of how an algorithm works, it's always like, why did it make this recommendation of this video? It's because this number was high and that added to this, and then this number came here, and when you add to this, you got 1 instead of -1, so I recommended this instead of that. Like, and sometimes it's so dense that you can't. Like, I can't tell you why ChatGPT answered something, but if I had a lot of time and a lot of like waste, I could maybe say, well, this number is bigger than this one, and this add to this, and therefore it said hello, right? So, but there's a conception, I think, that the computer is kind of human. So a lot of times I ask the question, and the answer will be like, well, the computer just figured out that it should give us that video. Like, but how do you figure out? Well, I just kind of looked around and thought about it. Like, maybe I'm exaggerating it, but there's a bottleneck that people tend to believe that there's that some part of the algorithm the computer just looked and figured out. And I try to emphasize, no, it's always just numbers that move.
Yeah.
Maybe we can figure them out. Maybe it's too many numbers for us to figure out, but there's nothing human about it or magical.
We don't even necessarily need to know exactly what math is being done. We just have to know the main ideas, that it's not magic, and that these are the basic principles that it operates on. That's enough, I think, for everybody, except for maybe one person. But everyone else, we just need to know the main ideas, and I think that's sufficient to developing sort of a creativity and like, well, what can we change? What can we do better? It's like a whole, and all of a sudden you can become part of the conversation rather than someone where it just goes over your head and you ignore it all and, you know, maybe duck.
So you guys both take really complicated concepts and distill it down and make it really, really easy to understand. Which I love. I watch both your YouTube videos.
Thank you.
But like, how like, what's the process? Like, do you go in and say, okay, I need to learn this myself, and then I'm going to come up with a way, you know, like the embeddings, pulling apart, the gravitational pull, so the context, you know, that was like a really powerful way to understand it. But like, how did you come up with that?
Thank you. That it took years. I think it took me years to think. That's why technology sometimes jump over me, because it takes me so long. I think I've had so my strength of being a good explainer comes from a big weakness, which from being a really bad understander. Like, but I'm not. I can't emphasize enough how bad I am at understanding, and that makes me really slow in talks. I'm always lost, and I have to read many times, and because I can't speak in high level, even when I try to. And so I have to bring it down to an example with an apple and an orange, or like some dog running around. It has to be for myself. I've done that all my life. When I was doing a mathematician, I did that all my life, and I was slower than than the others because I had to do that. And so I have that tendency, and that I have a bit of an obsession. I really like it, and so I just think about it a lot and look at examples. I have some techniques that I use, um, that are like shortcuts. For example, when I see a loss function, it's a sum of logarithms always. That's the logarithm of a product. That product is always numbers between 0 and 1, so it's got to be some probabilities. And I just make a game that the probability of winning at each step is that. So that takes care of like half of my videos. If you take a look at, a lot of them are exactly that trick, and I have a few other tricks. But yeah, I just look at the formula, and I try to look at it geometrically. So when I see a matrix, I think of the what transformation does it do. When I see, like, I try to draw a picture of everything, and when you draw enough pictures, the things start moving. And I try to bring everything down to like 2 dimensions. Like if they say 1,000 dimensions, I have to draw it in the plane. If it's an image, I have to bring it down to a 2 by 2 image with one monochromatic, so it's 4. Like I always bring, if it's text, I have to bring it down to like an alphabet of 4 words that you can make sentences. So if you bring it down to the very, very like the smallest possible example that captures the complexity, I feel like I can play with it. And now I use ChatGPT a lot. Like I just go, can you help me with this? Or DeepSeek, actually even better. Can you help me understand this? And it gives me the normal Wikipedia. And they go, well, what if I had n equals 2, and what if I had an apple, and maybe, that kind of stuff. So it's been very helpful. Yeah, but the short answer is I think like that. I'm obsessed of doing that. So I'm always thinking in that direction. Yeah.
Yeah, I think Lewis and I are kind of the same in our approach, in that we're both a little on the slow side. But not in a bad way, apparently. It's I always say, when there's I haven't actually interviewed for a job in a long time, but there used to be this standard interview question. It was like, what's the one weakness you have, and you always turn that weakness into your superpower. And you would say, my weakness is that I'm a slow learner, and learning stuff is really hard for me to do. It's really hard. But that ends up being my superpower of, if I can teach myself what's going on, other people might understand it as well, if I just keep track of what it took to teach myself. And so it's so a lot, maybe one misconception people have at 2025 is that I actually know all of machine learning and all of AI, and that I just go, I think I'm going to teach these subjects now. And it's the opposite, right? I don't know any of it, and I go, oh, I want to learn these subjects now. And the videos are me teaching myself, and it's my process, and it's my curiosity. What you're seeing in StatQuest is my little quest to teach myself, and it's my curiosity that drives each one. People ask me, well, how do you pick what your next video is? I go, well, I pick the one that I'm really just dying to know, and I literally am like, I remember very first time I ever heard about neural networks was when I was an undergrad, and I can't remember the name of the guy that was talking about them, but he was very dismissive. And he was like, oh, they're just blah, blah, blah. And I didn't understand any of what he was saying. And I remember going, oh, I don't like that feeling of feeling left out of the conversation. Mm-hmm. And then I think 20 years later, I finally figured it out. So I was very persistent, and I just kept going for it. And now I'm like, oh, if that guy ever comes back around, I can participate in the conversation with him. That'll be cool. He's probably on something well past that, but I use these tools, and I go, this is really cool. I wonder how this works.
Yeah.
And so it's my curiosity that sort of drives what I want to learn, and then I have to figure it out, and figuring it out is always painful. I have some tricks too, which is whenever I see a big equation with Greek characters, I replace those Greek characters with Roman characters that spell out exactly what it represents. So if, like, I've done statistics long enough that when I see a sigma character, I don't freak out and go, what the heck is that? But I used to just write in variation. I would rewrite the equation, and I would say, this is variation times the mean or the average or whatever. And I would rewrite things just in terms of words. And all of a sudden the equations would make a lot more sense, because mathematicians, I feel like math was developed in a time where paper and pen and all those things were really expensive and scarce. And so they were like, how can we collapse all this knowledge into like 2 sentences, right? And the mathematicians have never gotten past that scarcity of like parchment and quill. And so they're just obsessed with that. And like linear algebra, right? When I was learning about, when I was first trying to teach myself neural networks, I was Googling all these things and looking at them, and they'd all show me this equation. And it was a matrix equation of like, the weights and the biases. And it was all done in like matrix multiplication notation. And I was like, oh my gosh. I remember taking linear algebra in college, and I remember just hands sweating every day that they were going to be like, and now extract the eigenvalue. And I was like, no, I can't do it. I don't understand. And so I looked at that matrix equation. I went, okay, don't panic. Don't panic. Remember, it's just multiplication and addition. So you can write it out longhand. And that's what I did, is I broke apart all those equations. And part of that was part of the way I could do that math by hand instead of doing it in an abstract, hyper condensed matrix formula. I came up with the simplest example I could possibly think of. I came up with a data set that had 3 data points in it. And I was like, well, I can do the math for 3 data points. And then I came up with the neural network that only had one. It was very simple. I had 1 input, 1 output, and then 2 activation functions in the middle. And I could do all the math by hand. And when I did all the math by hand, I saw it. And I was like, and what I saw was something those matrix equations would have never shown me. What I saw was what that math was doing was it was transforming those nonlinear activation functions. It was transforming them. It was the things that Lewis was talking about earlier. It was split. It was shifting them. It was rotating them. It was stretching and bending, not bending, but like pulling. And I saw what was happening. And then it would just add everything together, all those things together, and everything, all those bent up, flipped over, not twisted, but stretched out activation functions collapsed to a squiggle that fit the data. And I went, I get it. And then I started teaching people that, and people that had like looked at the linear algebra and accepted it because they understood the math were like, oh, that's what's happening. And it's weird that I was the one that showed them to it, because I think there's some moral to that. Even if you are super comfortable with the mathematics, you're like, yeah, matrix algebra, no big deal. Even when you're super comfortable, there's some value to visualization and seeing it. And if you can see it, I mean, all of a sudden the main idea no longer is the equation. The main idea is you're going to take, shapes, and you're going to flip them around, and then you're going to add them back together, and you're going to get a squiggle that fits your data. Bam. That's a neural network.
So I think we have time for one more question.
Okay.
Who wants the final question? One final question. Else, I ask something about furniture and you don't want that. Or you don't want that.
Yeah.
What's that?
Is there another YouTube question?
There is a compliment.
Oh. Is my dad on it? My dad said he was going to watch.
Is his name Eric?
Is it in
No.
Spanish? Is my mom too?
You have an incredible talent for conveying knowledge in a tangible way.
Keep reading. Keep reading. This is good.
Please go ahead. Make up stuff.
Yeah.
You are so good looking, talented. You sing with the voice of an angel. When is the time up? No, there is also I'm not quite sure if that's the question.
Mm.
I have a bit. Oh, sorry. Yeah, of course. I have a bit of an OCD about poor level of teaching in most universities / online courses, where most teachers take the shortcut and skip over the math and intuition, or assume a lot of terms are already known. We need to pay more attention. Where am I? I need to pay more attention to the pedagogical English
Yeah, right.
aspects, or get replaced by AI tutors who can unlock that kind of learning. Are you afraid of getting replaced by AI tutors? No.
First of all, thank you for the. First of all, let me add that that's completely true. That and the education, the formal education is so terrible. I couldn't never understand anything, and I thought I was stupid for the longest time. And I think it's just, I don't know, when you put when you put people, evaluate them by research and make them teach, that those things are not the same skill, right? So that's why most of the professors we have are terrible. Some of them, we had that one good professor or something. It should be all of them, you know. Like, imagine if doctors were really bad at being a doctor, you know, like that's professor really bad at teaching in general. That drives me crazy. So I'm completely right about that. In terms of being replaced, I think I'm not really, I think the technique is try to get replaced as much as you can. I tried the hardest to get replaced. I try to get it to say the stuff I want to say. And then if you do that, I think, and this is profession agnostic, if you try to get replaced as much as you can, you may get replaced 99% of the time. And there's that 1% that doesn't, right? And that 1% is your essence. And that's what you should be doing. And the mall should be doing the other 99%. So a lot of times the mall can figure out the stuff that I figure out, or turn the equations into images and make them move around. That's something that's replicatable. Maybe something that's hard is, I don't know, the empathy that I feel with someone who doesn't understand, right? Or like, for example, like I know how to get lost in so many ways because I've been lost in so many times that kind of stuff. I feel like that's the core, and you can get to dictate to the model that the model can do a lot of my working things out on a piece of paper. So I do like to try to get replaced, and I think that's the best way to go.
I don't know about that, but
okay. It's good.
Yeah, but so my attitude is, if I get replaced, great. And the reason being is that means everybody understands the purpose of my channel is just for me to chase my curiosity, and which, you know, so I can do that no matter whether people watch it or not. And if people stop watching it because they're all educated some other way and they all understand and they've all gotten that enlightenment, that's great. I don't want to be the one that gets in the way of that or raining on that parade. That's fine. But what I've always done, and I found this to be very successful in my various careers that I've had throughout my life, which is just try to be useful. That's what I've always tried to do is I look around and go, what needs to get done that isn't being done? And I've always found great success in identifying that. I just look around and go, well, nobody's really teaching statistics the way that makes sense to me, so I'm going to do it. I'm going to do it. So I have to do it. So I do it. You know, one of the very first jobs I had right after college, it was kind of a silly job in that I worked for a guy who was not a good boss, and he was into technology, and he'd always say this goon babble stuff, and he'd just string a bunch of tech words together and tell me to do it. And I'd go, okay, I'll go do that. But what he asked me to do was actually not something that took a long time. What he really wanted me to do was on the way out of his office, after he'd told me all this stuff, I'd be walking out towards the door. I'd open it up and he'd go, oh, by the way, my printer stopped working. And that's really what he wanted me to do, is fix his printer. And usually the printer would be just blinking out of paper, load tray 1. And so I'd slam a ream of paper in there and slam it shut, and it would start printing out stuff. And I go, printer's working. He's like, great. I'm so glad you work for me. And I worked at a hospital, and I just wandered around I don't know if you can do this anymore, wander around the halls of a hospital, but I was a computer programmer with nothing else to do because I'd fixed the printer at 9 a.m. and I had the rest of the day. And so I ended up, and this is going to sound weird and creepy, but I ended up outside of the neonatal intensive care unit. And they were like, because there were these little tiny babies in there, they're kind of cute. You could see them through the window. And the doctors were doing all this crazy stuff. So newborn babies, when they're premature, they still need to grow and develop, and they have to eat this very specific diet that is measured in like ions. They're like sodium ions versus calcium ions and blah, blah. And they measure, it's like basic chemicals. It's really weird sounding. But the thing is at the time, all the doctors were doing the math by hand. And they were like, yeah, and sometimes we mess up. And I was like, what? Yeah, and we got to do the math again. And they're like, you guys are really high paid doctors to do math? And I'm like, I can write a program where you just punch in, like, if you know how much sodium they need, we can figure out everything else based on the formulas you've got. We can just make up a website that does it. You punch in the sodium and it gives you everything else. And they're like, you can do that with computers? And I would do that. And those people were like, and they were like, we're hiring you. They just, I found a way to make myself useful, and that gave me job security. And it wasn't the job itself that was important to me. It was just that I felt like I was being useful, and that's what made me feel like I was doing something important. And blah blah blah. I've gone too long. Okay.
That's a great ending.
Yeah.
Thank you very much for insights. Thank you
Yeah.
very much for all your questions.
Yeah.
And I think you have deserved a round of applause. Thank
Aw.
you very much.
Thank you.
I think it's time for a pause now. I'm not sure if there's follow pause. 30 minutes pause.
Are we still streaming?
Yes, you have to go on.
Yes, I will stream it. Yeah.
Thank you all for who was in the live section.
Oh, you did already?
I did. But why the ukulele?
Oh, so there's a story behind it.